So in the second video, we're going to look at Learning Objective 3, where we're looking at a binomial distribution. Now, a binomial means that there's only two. There's only two options. So in a binomial distribution, we only have two possible outcomes. We've defined those as a success, or P, and failure, which is 1 minus P, or the complement of P. Now, we don't have to call them success and failure. You can call them, whatever you want to, but success and failures is kind of a good way to think of it. So we use what's called the Bernoulli process, and the Bernoulli process says that this is for an experiment that is for independent and identical trials. Identical trials here. My pencil's not working very well to write on it. So if we have independent and identical trials of an experiment, then we can use the Bernoulli process, assuming there's only two possible outcomes. So looking at the binomial distribution, so we're going to define our binomial random variable x as the number of successes achieved in n trials. So n is our sample size, remember. And so we have the formula down here to calculate the probability of x number of successes, and boy, that's a booger, isn't it? But we're going to do it in Excel, so don't even have to worry about that right now. So let's look here. The expected value, or the mean, is equal to n, the sample size, times p, the probability of a success. So the expected value is the probability of its success multiplied by the number of items in our sample. So the variance then is the mean times 1 minus the probability of its success, and of course the standard deviation is just the square root of that. So let's look at our data here. We're told that in the United States, about 30% of adults have a 4-year college degree. We're going to say, assume that 5 adults are randomly selected. So n is our 5, and 30% is our probability of success. So that means our probability of failure, remember, is 1 minus 30%, or 70%. So we're going to look at some questions. What's the probability that none of the adults has a college degree? What is the probability that no more than 2 have a college degree? What is the probability that at least 2 have a college degree? And then we're going to calculate the expected value, the variance, and the standard deviation. Now, if we look here, we have the formulas that we're going to use in Excel. And so we're, of course, going to be focusing on this top box here, this binomial distribution. Again, I don't know why my pen's not working. But we'll use the Poisson distribution and the hypergeometric formula distributions in the next following videos. So now let's jump over to Excel. Now notice that we don't have a Chapter 5 starter file. It's not that I forgot to upload one, we don't have one. I've opened up a blank Excel workbook, and we're just going to start working here within the formulas. So the first thing that we were asked is, what is the probability that none of the adults have a college degree? So I'm going to put this up here in A1. So this is the probability that x is equal to 0. And so if you remember, our formula was binomial distribution, and then we can start just typing this in, or we can go up here to our formulas. Let's go up here to our formulas part here, and I want more functions, and I want statistical. I'm looking for binomial distribution, so that's binom.dist there. And so number is looking at what is my probability. I want the probability that x is equal to 0, so I'm going to enter that as a 0. The number of trials, again, is my sample size, so in this case that is 5. The probability of a success, remember, is 0.3. We were given that. Now this cumulative, the cumulative we will enter as a 0 if we enter it as 0 if we're looking at the probability of a greater than or equal to. If it's a less than or equal to, we'll enter as 0. So we're going to enter a 0 here because this is a less than or equal to or an equal to. And so here we're told the probability that 1 out of 5 people randomly selected does not have a college degree is approximately 16.8%. So I believe the next question that we were asked is, what is the probability that no more than 2 adults have a degree? So here we're looking at the probability that X is less than or equal to 2. So now I'm going to go up here, I'm going to enter the binomial distribution again. Let's do it this way. So again, my number here is 2. I'm looking for the number 2. I'm looking for 2 or less adults. My number of trials is 5 still. The probability of success is still 0.3, but now because I want a less than or equal to, I'm going to enter a 1. Okay, so it's a 1 then because I'm looking at that less than or equal to. So I'm going to enter it as a 1. It's a cumulative distribution now. I want to know how many people up to and including 2, so that's a cumulative distribution as opposed to a discrete distribution like how many are exactly 0. All right, so this tells me that 83.7% approximately of people we have an 83.7% probability that at least that 2 or less people, goodness, have a college degree. I said that backwards and then I lost my words right as in the middle of speaking. So there is an 83.7 approximately % chance that 2 or less have a college degree. So the next question that we were asked is, what is the probability that at least 2 people have a college degree? So this is the probability that X is greater than or equal to 2. So at least 2 or more. Now remember the formula. I'm going to go ahead and type this over here a little bit. If we're looking for a discrete probability, we're going to enter a 0, okay, as the last term. If we're looking for a cumulative probability, we're going to enter a 1 as the last term. Well, we're not looking for a discrete or a cumulative here. We're looking for a greater than or equal to. So this is a different one. So because we want a greater than or equal to, we're essentially looking for the complement of the cumulative probability. So we don't want what's adding up, we want what's left. So we're looking for the complement of the cumulative probability. So then we're going to say 1 is the last term, but we're going to write the formula as 1 minus, just like we did with our probability. So here my formula now, this is where we need to kind of pay attention. My formula is going to be 1 minus the probability of the binomial distribution. Now, I want to know, because I want to know 2 or more. Remember, my probabilities are, I have 0, 1, 2, 3, 4, or 5. I want to know 2 or more. How many, what's the probability that 2 or more people have a college degree? So what I'm really looking for is the complement of that. So I want to say, what is the probability that 1 or less does not have a college degree? So my first term here that I'm looking for, the number is 1. I want to know what's the probability that 1 or less out of 5 trials, remember my probability of success is 0.3, and then again I'm going to put a 1 here in the last term because it is a cumulative probability. So pay attention here, because I'm looking for cumulative is less than or equal to. Because I'm looking at a greater than or equal to, I have to really look for the complement. So I have to say 1 minus, but it's not 2 or less, it's 1 or less. So the complement of the probability that 2 or more people has a college degree is 1 or less people has a college degree. So that's what I'm looking for here. 1 minus the probability that 1 or less people has a college degree. So I get approximately 47%. So there's a 47% probability that 2 or more people have a college degree. So now I can also go in here and calculate the mean, or the expected value. So let's drop down here, and so I can say the expected value of x, remember that's n, which is the number of trials, 5, multiplied by the probability of success, which is 0.3. So my expected value is 1.5. Now I can easily calculate the variance by, remember our formula is the mean, that 1.5, multiplied by 1 minus the probability of success, which if our probability of success, if p is 0.3, let's maybe go ahead and write this over here. N equals 5, remember p equals 0.3, and so 1 minus p is 1 minus 0.3, or 0.7, right? So my formula for the variance is the mean, or the expected value, multiplied by the probability of failure, the 1 minus p, or 0.7. So I get 1.05. And then the standard deviation of x is simply the square root of that value. So square root is SQRT, is the square root. So the square root of this value here in the variance, and I get 1.02 adults. Now, last thing, let's say that I want to depict the binomial distribution graphically. So first of all, I'm going to need to calculate the probability for all of my possibilities of my chances. So I already know that the probability of x equal to 0. I've already calculated that, so I'm just going to go ahead and copy that formula down. I press Control C and then Control V, and I've copied that probability down. But in order to graph it, I'm going to need to calculate the probability that x is equal to 1, the probability that x is equal to 2, the probability that x is equal to 3, the probability that x is equal to 4, and then lastly the probability that x is equal to 5. So really I can just drag this formula down, but I just have to change that first term. So remember, the first term is what you're looking for, the probability that x is equal to 0. The second term is the number n. The third term is the probability of success, and then the last term is asking you, is it a discrete or cumulative probability? Since these are all discrete probabilities, I'm going to leave those all as 0. Come down here. There we go. So I need to go in each one of these. So here the probability that x is equal to 1, I'm going to change to a 1. The probability that x is equal to 2, I'm going to change the first term to a 2. The probability that x is equal to 3, I change the first term to a 3. Probability that x is equal to 4, I change the first term to a 4. And then lastly, the probability that x is equal to 5, I'm going to change that last term to a 5. So now I can graph all of these. I can grab all this data. I can go to my Insert tab. I can go to Charts here. Let's see. This looks like a good one. Let's do that clustered column chart. And here we go. So now I can graphically see this probability distribution. I can see that it is not symmetric. It is positively skewed. So I could see that the highest probability is that 1 out of 5 people has a college degree. The probability that all 5 have a college degree is obviously really, really low. It's actually less than 1%, right? But now we have graphed this using our clustered chart. So we're using all of that information that we've learned in the first 4 chapters. The reason we spent that time on that is we're going to keep using this and keep learning it.